basic rule of the trigonometric function of the sin x, say this is one trigonometric function, d by dx of sin x. From the first principle you can write differentiation of sin x as a cos x, and from the first principle, if it is written here d by dx of cos x, so we would get from here minus sin x. This is the main basic rule of the trigonometric function sin x cos x. By using this two differentiation, we can do a lot of differentiation in a row. Say I'm going to write here the expression sin, if it is written here 2x. What is the differentiation of that? So first we need to differentiate as a sin becomes as a cos, right there cos, inside whatever it is written we needed to write it, then d by dx of inside the bracket it is 2x right there, and from if we differentiate d by dx of 2x, so we got from there 2, so we can write it cos 2x into 2, so the final answer 2 cos 2x. We cannot multiply this 2 and that 2 because this is inside the trigonometry, that 2 is just a constant, we needed to write in front of it. This is our answer of this question. Say if I consider another question, sin, it is written here x square plus x plus 1. What is the differentiation of this? D by dx. So according to the rule of differentiation, first we needed to write cos of the whole thing x square plus x plus 1, then if we differentiate inside the bracket we got from here 2x plus 1, so our final answer would be 2x plus 1, then cos of x square plus x plus 1. So this is our answer of this. Same way, if it is written there, say sin 2x plus pi by 3, what is the differentiation of that? So according to the basic rule, we needed to write first cos 2x plus pi by 3, then if we differentiate inside the bracket we got from here 2 just, so right here 2 cos 2x plus pi by 3 is our answer of this equation. Let's move to the cos. If it is in a similar way, if it is written here say cos x square, how to differentiate this? So we know if we differentiate the cos, it gives us a minus sign, then whatever written inside the bracket we needed to write it sin x square first, then d by dx of x square, and d by dx of x square, from there we got 2x right there 2x, and our final answer would be minus 2x sin x square. This is our answer of this question. Let's see one more example. If written here cos 2x minus pi by 2, what is the differentiation of that expression? Same, it is, we needed to write here minus sign first, and this minus comes from the differentiation of the cos according to the first principle, then minus pi by 2, and it beside it we needed to differentiate 2x minus pi by 2, we got from here 2, so final answer would be minus 2 sin 2x minus pi by 2. This is our answer of that expression. So that is the total working of the sine and cos of the basics. Say if it is written here cos square x, how to differentiate this? We needed to differentiate first as a power of the whole expression. Actually this we can write as a d by dx of, which is we can write here cos x whole square is the same thing. So if we differentiate that, 2 comes first, then from the power we needed to minus, we need to subtract 1, then into differentiate inside the bracket, and we got from here minus sin x. So it gives us minus 2 sin x cos x, and finally you can write according to the trigonometric rule. We know that 2 sin a cos, we can write it sin twice b, which is sin twice x. We can directly write that like this. So same way, if it is written here, say d by dx of sin cube twice x minus 1. How to differentiate this? First we need to differentiate as a power, say 3 first. Then from sine we are subtracting the power. 3 minus 1 is 2, and inside its angle is twice x minus 1 into d by dx of sine. We can write that like here, sine 2x minus 1. So now put it 3 sine square 2x minus 1 into, inside the bracket, if it is written there sine something, so sine is converted to the cos 2x minus 1. We are going to apply here the chain rule. 3 steps we needed to apply. So now we are going to differentiate that part, and from here if we differentiate we got 2 only. So now simplify and write the final term, t to the 6 sine square 2x minus 1, then cos 2x minus 1. This is our answer. We also can write it in a more simplified form, but we can leave our answer right here. So similarly, I am going to explain a few more questions. Say if the expression is given here 1 by sine 4 3x, what is the differentiation of that? By writing it according to the rule of indices, you can write it d by dx of, say, sine negative 4 3x. So negative 4 3x, we know first as a power we are going to differentiate, which gives us sine negative 4 negative 1 gives us negative 5 3x. Then inside the, what it is, the sine part we are going to differentiate now. If we differentiate sine, it gives us cos 3x, and if we differentiate the 3x, we got from here 3. So this is the three stage. I think it's, we needed to, if we break down, we did the u, v and g, we needed to part it in the 3 parts, but we can do it without making it 3 part like that way. As a first, we did the first part as a power, second part differentiation of the sine, third part inside the sine what written, we got like this. So finally you can write it 3/4 the 12, and negative sign keep it in front of it, 3/4 the 12, and sine negative 5 we can write as a denominator sine 5 3x, and another part we got from here cos 3x. We also can it can be written as a more simplified form by applying the double angle formula, but still we can leave our answer here according to the rule. So this is the part of the differentiation. Let's see the another part. If it is written with the function to variable as a multiplication x sin x, in that case we have to apply the product rule, so which is x d by dx of sin x, then plus sin x into d by dx of x. So from there x cos x, because differentiation of sin is cos x, then sin x into 1. So we needed to write our answer because nothing here to take common. So x cos x plus sin x, this is our answer. Even if it is written here, say with the division, say d by dx of cos x, and below is given x. So two variables are here, two functions as a division. So we needed to apply here the quotient rule, v d by dx of cos x d by dx minus cos x then d by dx of x, and on the denominator it is x square, because this is the rule of the UV rule. So just now differentiate. X into sin x gives us minus sin x minus cos x into 1 divided by x square. So finally we can write our expression like this: minus x sin x, then minus cos x on the top, and below is x square. This x and sin x cos x we cannot cut out because sin x cos x it's the uh, angle for this sine and cos, so we can leave our answer here. This is our answer of that expression. So next we prepared another question. Say by using of this sin x, what is the differentiation of tanx? By breaking down it, d by dx of sin x by cos x, we can write the part sin x by cos x. Now let me apply here the quotient rule, then we'll get it. So cos x d by dx of sin x, then minus sin x d by dx of cos x divided by cos square x. So we got from here sin x cos x cos x into cos x minus sin x into again cos x. If we differentiate, we got minus sin x, and the below it is cos square x. So which gives us cos square x and minus plus sin square x, and we know from the trigonometry sin square x plus cos square x equals to 1. So this we can write as a 1 by cos square x. This is our answer. We also can leave our answer 1 by cos, we know sec x, so we can write it as a sec square x as well. So this is our differentiation of the tan x. If sin x and cos x as a given exponential, say e to the power sin x, how to differentiate it? D by dx. We know how to differentiate the exponential, so we need to write the full thing is sin x first into d by dx of sin x, and from there we got cos x, so it is e to the power sin x into cos x. So finally you can write it cos x e to the power sin x, and this is our answer of that part. So let's see a few more examples. Say it is written here e to the power, say it is written here x plus cos x as a power it is given, so d by dx of is that one. We know according to the rule of exponential we needed to write it e, same thing, x plus cos x, then differentiation of d by dx of x plus cos x. On the top we are going to differentiate, then we got from here e x plus cos x into 1 minus sin x, because differentiation of cos x equals to sin x, so finally you can write it 1 minus sin x first, then e to the power x plus cos x, and this is our answer of that portion. So if trigonometric function written as a ln or logarithm, say ln cos x, how to differentiate it? So we know differentiate of the ln x is 1 by cos x. As a ln we differentiate first, then d by dx of cos x. D by dx of cos x is cos x, and we needed to write 1 by cos x into d by dx of cos x is minus sin x. So it finally gives us minus sin x by cos x. So you can write it as simplified form by minus tan x, and this is our answer of this question. Because before I prepared one worksheet for you which is differentiation with respect to trigonometry, all of the trigonometric functions as a power, as a multiplied form, double angle formula, product rule, division rule, the questions I have shown you, you are able to solve everything from here. So this has been uploaded in the description below. You can download this PDF file from this description below. Write comments below if you would stuck in any question while you are solving it.